Solving quadratic equations using the zero factor property. What this means is if we are able to factor an equation, so say we have x plus 6 times x minus 1, and we can set that equal to 0, then there's a little bit that we know. We know anything times 0 is 0. So that means if we could make x plus 6 equal 0, whatever times 0 would give us 0. If we could make x minus 1 equal 0, then whatever times 0 would equal 0. So that means we can solve this down by manipulating it to make x plus 6 equal 0 or x minus 1 equal 0. To solve this, we would solve normal. So we would subtract our 6 from both sides. Here we would add our 1 to both sides. And that gives us x can be either negative 6 or 1. Substituting negative 6 right here would give us 0. So that gives us 0. Substituting 1 right here would give us 0. So the multiplication would give us 0. Let's try again. If we have 3 times a minus 5 times a plus 2 equals 0. Well, the 3 is not doing us any good in the front. It was part of our factoring when we factored our pretend equation that we factored to get to here, but it's not doing us any good. So we could just divide both sides by 3, and that will leave us with a minus 5 times a plus 2. 0 divided by 3 is still 0, so that doesn't change. Then a minus 5 equals 0, and a plus 2 equals 0. So we're taking each of our factors and we're setting them equal to 0. This will give us a equals 5. This will give us a equals negative 2. So our two solutions here would be 5 and negative 2. Let's try again. Let's say we have 3y to the second equals negative 24y. We don't want to start dividing and canceling, because if we do that, we might eliminate potential solutions. Instead, let's set it equal to 0 and factor. So we have 3y to the second plus 24y equals 0. We have 3y in common, so let's pull that out. We're left with y plus 8. So that means our two factors are 3y and y plus 8. So we can set each of those equals to 0. If we divide both sides by 3 over here, we get y equals 0. And if we subtract our 8 from both sides here, we get y equals negative 8. So those are our two solutions. Let's try again. There we go. X squared minus 6x plus 5 equals 0. So the first thing that we need to do is factor. So from our previous video, if you remember the AC method, we can multiply 1 times 5, and that gives us 5. And then we can look at our common factors. So if we work this through using our AC method, we would have 1 times 5, that's 5. Our factors are only 1 and 5. We need 6. So we need them to add to 6. But I need negative 6. So that would be negative 1 plus negative 5 to get negative 6. If we split it out, there we go. Negative 1x minus 5x gives us negative 6x. We can do our grouping. What's in common here is x. What's in common here is our minus 5. What's in common is our x minus 1. What's left over is our x minus 5. Now we've gotten it to our factored form. So that means we have x minus 1 equals 0 and x minus 5 equals 0. So here we get x equals 1, adding our 1 to both sides. Here we get x equals 5, adding our 5 to both sides. You do not have to do the AC method to factor this. You can factor using guess and check or any other method that you like. This always works, so I just showed you that way. Let's try another one. X to the third equals negative 19x squared plus 42x. Well, this won't work. We have to have it equaling 0. So let's do some cleaning. I don't like the negative right here, so let's move that over. So we have x to the third plus 19x squared minus 42x equals 0. Hopefully you're noticing an x in common, so let's pull that out. There we go. So now we need two numbers that are going to multiply to 42 and multiply to negative 42 and add to 19. So if you want to do your AC method and work it down, we need to multiply 1 and 42 and we get 42. Look for your common factors, and then you can use your factor by grouping. If you'd rather use your guess and check, we need two numbers that multiply to negative 42 and add to 19. So we're going to get 21 and 2. So our positive 21 and our negative 20 and our negative 2 will add to our 19. So now we can set our factors equal to 0. But look at this one. We have 3 factors. See that x right there? We can't forget that one. So that means we have x equals 0, we have x plus 21 equals 0, and we have x minus 2 equals 0. So x equals 0, that one's solved. This one will give us x equals negative 21, and this one will give us x equals 2. Let's try one more. X plus 7 squared minus 16 equals 0. This is actually a difference of squares. Remember that special case? We have x plus 7 squared, and we have 4 squared to get 16. So this will look like x plus 7 minus 4 and x plus 7 plus 4. So that means that x plus 7 minus 4 equals 0, and x plus 7 plus 4 equals 0 would be our two splits. So this gives us x plus 3 equals 0, or x equals negative 3. And this gives us x plus 11 equals 0, or x equals negative 11. So we've been able to solve down for our two factors. Let's try a different type of question. So let's say that we're given f of x equals 4x squared minus 11x plus 2. And let's say that we want to find all the values where f of x equals negative 4. So if we want to do that, that says negative 4 equals 4x squared minus 11x plus 2. Well, we can't use it in that form. We have to get equals 0. So let's add our 4 to both sides, so we have 0. I can't factor anything out, so we're going to need to use our AC method to try to factor. Once you use your AC method, we can set it equal, each factor equal to 0 and solve it down. Our AC method says 4 times 6. 24 is 1 and 24. 2 and 12. 3 and 8. 4 and 6. And I think that's all of them. So looking down through our list, we need to be able to get to 11. Well, 8 and 3, that'll give me 11. So let's use that one. do our grouping, pull out what's in common, pull out what's in common, write what's left over, and then we can set each of our factors equal to 0. X minus 2 equals 0 will give us x equals 2. And here we would add our 3, so we will have 4x equals 3, so x equals 3/4. So here are our two solutions.